factor n squared minus 6n plus 9. This looks similar to some of the perfect square trinomials we've seen before, in that it is a trinomial. We do have two terms that are perfect squares. N squared is n squared, and 9 is 3 squared. But there is a major difference here, and that difference is that the middle term is negative, but that's not actually a problem, because there are two different formulas for perfect trinomial squared. The first is f squared plus 2fl plus l squared equals f plus l times f plus l. But there's a second, f squared minus 2fl plus l squared is f minus l times f minus l. So if we have a perfect trinomial square and that middle term is negative, what that negative does is it turns the two factors into differences. So let's make sure that this works out, especially the middle term. The middle term has to be twice the product of the two things that get squared. The product of n and 3 is 3n, and 2 times 3n absolutely is 6n, so that works. But because it's a negative 6n, this is going to be a difference times a difference, so it's going to end up being n minus 3 times n minus 3. It's the only difference. If it had been n squared plus 6n plus 9, it would have been n plus 3 times n plus 3. But now, because it's n squared minus 6n plus 9, it's n minus 3 times n minus 3, or, of course, n minus 3 squared. Also an acceptable way to write the answer. The one thing that can't be negative is that last term. If we ever have a minus 9 or a minus something else, it will not be a perfect trinomial square. And in that case, we have to try and factor it using unfoiling or the AC method.